Let's run through another example for importing characters and talk about some of the problems you may run into. We'll open up a scene, go to Program Files, Steam, Steam Apps, Username, SDK Content, HL2MP, Model Source, Humans, Male, Group 3M, Scenes. Okay, here we have Male 5 reference. So let me tell you that file path once more in case I ran through it a little too quick. C, Program Files, Steam, Steam Apps, Username, Source SDK Content, HL2MP, Model Source, Humans SDK, Male, Group 03M, Scenes. Open up Male 05 reference, and I've switched to using the mod tool version for the moment to illustrate a couple issues mod tool users might face. Alright, this is a base scene that comes with the SDK. What we're going to do is import a model, scale its proportions, and work with the weight maps. So let's import a model, File, Import, .xsi. And under DB201, in .xsi, and we have our Catwoman. The first thing you'll notice is she's a bit smaller. We have to freeze because she has an applied texture. So freeze the model. And now let's scale it. Something like that. Now with the first model, let's go to Valve Source and export its weight map. Place it in the root directory or somewhere it's easy for you to find. And export. Now erase the male character with delete. And now we just have our character. Import. Takes a few seconds. And there we have it. You can see that the skeleton is not connected, but we do have the weight map, which is what we want. Let's just smooth it out a bit by bringing up the neighborhood depth. Now, with our model selected, go to Valve Source and export SMD. And I'll just put it in the root of my hard drive since we're going to move it in a second anyway. Okay. Catwoman is exported. There we go. Now wherever you saved it, find the catwoman.smd. And for consistency, let's move it to the same directory that we've been using. Source SDK, Model Source, Humans SDK, Male, Group 03M. That way, we'll still be working with the existing animation library. Now I have to create a .qc file. In the extras folder, Catwoman, just move the .qc file to the same directory. Open up and take a look at the QC file. It's very similar to the other QCs that we've used. Here's where we can change the name of the object that we're going to create, and we'll give it textures. Now let's compile it. And when it's done, it should show up in the models folder. There we are. In Deathmatch Models. You'll notice that when we open it in the model viewer, we see something very strange. She's just sort of flopping around all over the place, and I'll explain why in just a second. But I want to show you what it looks like in case you run into a similar problem. What's happening is, if you can remember from other scenes where we've scaled characters, looking at the transformation values, they are not 1, 1, 1 like they should be. We could simply try to freeze our transformations, but let's see what happens. Transform, freeze all transformations, and because of our weight map, the scale comes back up and multiplies. So undo, and let's do the following instead. With the model selected, open your Explorer, let's look for the envelope operator. Select it and erase it. Now select the object and separate it from the hierarchy. We want to break it completely from the hierarchy. This one here is a null. We can just erase it. And now you'll notice the new transformation values, the correct values. So now freeze all transformations, and you'll see that it goes to 1, 1, 1 in our scale. So now we'll re-import the weight maps. And export an SMD. Copy the QC. Compile it. Takes a few seconds. Open her up again in the model viewer. And there it is. Now what if I want to go back and add geometry or otherwise just change my model? In XSI, select File, Import.xsi, and we have some wings that we'll try to add on, adding them to the existing geometry. First, remember to freeze the model to preserve the texture. Then let's cut it from the hierarchy so that it is not parented up to anything. Place the wings where you think they should be. I'm going to scale them up a bit. somewhere in there. Pull them back a little bit. Then align them up on our back. And maybe make them a little bit bigger. And freeze all transforms. Now let's take the two parts and choose Polymesh Merge. Adjust the tolerance, or use the blend option if you need. Then merge all attributes and delete the inputs. Now we'll re-import the weights. Weight map import. The correct file is already selected. It's going to try and assign values to the wings. So we'll check to see if they're okay, and if not, we can correct them. There we go. The wings look to have values assigned from the hands and the shoulders. I'm not sure that's really what we're going to want. But let's compile it and see what happens. Save your scene, valve source, export SMD. And when it's all done, we'll navigate over to the SMD. Yep, this is important. This error message is telling us that we have passed the limit of triangles. Now, if you remember, the mod tool has a compile limit of 7,500 triangles. And here we have 7,900 triangles. So it's going to crash. So if you saved your scene, just open it right back up. I'm just going to have to redo the last few steps. Select the model and wings object. Let's merge. Adjust the tolerance. Merge all. Close the property editor. Whoop. 8 for Explorer. Select the polymesh, polygon mesh. Click the merge meshes operator. And I'll delete the inputs. Alright, switch to the textured view to see how the texture is working. And let's look at the weights again. Locate your weight map. Import. Alright, this would be another good time to save. And now, before we export, let's get rid of a few polygons. Select the model, and we'll filter out some of the polygons. Model, modify, polygon mesh, filter polygons. And we'll just make a few adjustments here under incidence angle. Leave the window open while we check to make sure we're not losing too much detail. And you can see the results as you move along the slider. We could bring it all the way up to 3 or 5. And it looks all right. But I don't think we really need to be that extreme. So I'm going to select the model and bring it down so that I'm just under the 7,500 polygon limit. There, somewhere around 1.8. Now it's ready to export. Valve source, export SMD. And I'm saving to the root of C. Copy the new SMD into the group 03M folder. The QC file should be ready. Double check, and then drag it to the studio model.exe. When it's done, the model appears in the HL2MP Models Catwoman folder. Open it up, and we'll check to see how the default weights have worked out. Orbit around using the left mouse button to see how everything looks at rest. And it looks like the wings may have too much weight assigned in here, which causes them to get kind of pulled down and deformed. If we check out some different positions, we can see that the wings are actually changing with the position of the hands. And they get kind of pulled around at all kinds of odd angles. Not really the results that we were looking for. So let's fix it. Switch back to XSI. With the model selected, select some of the triangles of the wings. Then under Select, choose Grow Selection. It still hasn't gotten all the points, so middle click to grow the selection again, and keep middle clicking to grow your selection until we have all the wings selected. Now go to Select, and select Adjacent Points. It's going to be a bit easier in wireframe mode. Let's assign those points to this bone, which is the spine, the yellow bone. Go to Animation, Envelope, Local Reassign, left click to select the bone, and right click to end the tool. Now we can see the weights for the wings have all changed to yellow, and they will no longer be influenced by the arms. So export, and copy the SMD to the correct folder. Grab the Catwoman QC and compile it. Open the .mdl in the model viewer, and that moves a lot better. Just check out the wings. Make sure you check out the whole sequence, test out the rest of the animation library. And this is where we can really see the importance of the scale of the object. If they are parents or children of objects, they should all have a freeze on their translation, rotation, and scale. The model viewer really allows us to see how our models will behave inside the game. So in case we want to go back and modify our model in XSI, we can go make any adjustments, and then quickly see how it's working in terms of the weights and animations, until we have a model that we're really happy with. You can test out a lot of attributes, view the movement space, look at shadows, check out all the different types of walking, different gun holds and positions, all before we even launch the game. Hitboxes are boxes that surround all characters to determine where they can receive damage. They are attached to bones and belong to different groups. These groups are divided into numbers and colors, each of which determines the amount of damage it can receive from an impact. For example, we can see that each arm belongs to a different group, as well as the legs, the pelvis, the chest, and the head, which is one particular box that is more vulnerable to taking damage. Before we get into hitboxes, you need to first copy the contents of the two folders within your Database 201 Extras Neosis bot folder, and we're going to copy them into your username folder within Steam on your local hard disk. So from the Extras folder in Database 201, open the folder Neosis bot with Steam user in parentheses. We're going to copy these contents, these two folders, to C, Program Files, Steam, Steam Apps, your username, in this case it's Neosis 3D, and we'll copy those two folders right here into your username folder. Wait a few seconds while everything copies over. Now let's explore Program Files, Steam, Steam Apps, username, Source SDK Content, HL2 MP, Model Source, Humans SDK, Mail, Group 03M. These are the files we're going to use, our level of detail and QC file, and in Half-Life 2 Deathmatch, HL2 MP, Models, Neosis. This is the Neosis bot that we can open up in the model viewer. So make sure you have Steam running and the game is set to Deathmatch in the Source SDK. Let's open the Neosis bot MDL in the model viewer. Turn on the hitboxes, and note that by default, this model uses standard hitboxes which are calculated automatically when the model is created. The compiler actually uses the reference skeleton to add hitboxes to the bones. We will have to customize these hitboxes to account for our character's larger head and wings, since there are no bones in these areas. So let's go analyze our model's QC file a bit closer. In the bottom portion of the QC file, we have an instruction that calls for the hitbox.qci. You can find the QCI one folder up from the standard Model Source, Humans, SDK, Mail, Group 03M folder. And here you have the hitbox.qci. It's a text file where you can see the hitbox, the number of the group it belongs to, and which bone is applied or attached to, as well as the exact position in which the hitbox should exist. To create a similar table for our custom model, who needs custom hitboxes, we're going to enlist the help of the model viewer. So open the noesisbot.mdl again in the viewer, and check the box to view hitboxes. Switch to the Bones tab, and select the option Highlight Hitbox. Now, when we go down and select a bone from the drop-down list, it may also be helpful to select Highlight Bone. In this case, you'll see the spine doesn't have any assigned hitbox. If you switch to Spine 2, you'll see it has one hitbox, which is the chest. Here are the head, arms, and legs. Now if we look at the colors, you notice that they are related to the group numbers they belong to. Group 1 is the head, the group that will receive the most damage. Then there's the right arm in group 5, left arm, group 4, etc. To modify the hitboxes, first select the bone. We'll start with the head, and then we'll stretch the box to make sure it completely surrounds the entire head area. These 6 boxes will determine the hitbox origin and the hitbox size. The first number, let's change it to 15, adjusts the height in the global Y value. The second box sets global Z position that can be positive or negative. And the third box is the global X position, negative, positive. So the X, Y, Z values next to the boxes are relative to the bones the hitboxes are attached to, not global coordinates. The same with the hitbox size. If you enter 50, this is the size in global Y value. And in global Z, or depth value. So let's enter a number that is going to cover the entire head. And finally, the width of the hitbox. This is how we cover our custom head. Now let's add 2 more hitboxes that will cover our wings. We need to find the bone to which we can attach our new hitboxes. The head, the clavicle, arms, so let's select the neck 1. What we're going to do is add a hitbox, and let's position the hitbox over one of the wings. It may take a little bit of trial and error. Lower it a bit. Move it back a bit. And to the left. scale it. Maybe make it a little narrower. And now we have to assign it to a group. In this case, the right arm. If you look at the right arm, you'll see that it is in group 5. So return to the neck, select hitbox 17, and let's change the group number to 5. This way, it will receive the same amount of damage as the arms. Good. Now let's repeat for the other wing. Select neck 1, add a hitbox. Let's set up the origin. A little bit down. Back a bit. And to the right. Making it a bit smaller. And narrower. Now let's check our group number for the left arm. It's number 4. Go back to neck 1. Switch to our new hitbox 18. And assign it to group 4. The model viewer helps us to place these hitboxes. The next step is to recompile the model. Go back to the Bones tab and click Generate QC. When you select Generate QC, it actually copies the hitbox values to your computer's clipboard. So now, open up your existing QC file and we'll replace this line of code with a new custom hitbox file that we will create, called hitbox Neosis bot.qci, and save. So let's actually create the file. Right-click, New, Text Document, name it hitbox Neosis bot.qci. Open it, and let's paste in the contents of the clipboard that we generated when we selected Generate QC inside the model viewer. It's actually a very useful feature inside the SDK. And finally, now when we have all the pieces in place, let's actually compile the model. Once it's compiled, we can open it in the model viewer, take a look at its hitboxes to make sure everything appears in order, and there you can go. You can see each of our hitboxes applied. Let's talk about character scaling. This is also very important. Because we're going to be using the standard animations that come default with the various existing characters in Half-Life, we could have some problems with scale. In this case, you see two characters. One with the standard default rig scale, and one with the reduced scale. If you notice, they are actually both using the same rig. Both rigs came from the Valve Source character Biped guide, but the second was reduced to match proportions of the second, smaller dwarf character. If you look at the compiled model inside the model viewer, some poses will appear correctly at the smaller proportions, but with other poses or animation cycles, let's choose Run RPG, you'll see the character gets scaled up to try to match the standard animation size. All the bones actually get stretched to try and match those of the standard scaled characters. This is important since this is actually how the guy would look inside the game. And it's making some proportions of the body very awkward and isn't at all what we had in mind when we were designing. It is possible to create our own custom library of animations for each of our characters. I've got an example here of a new custom walk cycle. After we compile it, the sequence appears within my animation library. And it works pretty well. And here's another example of a compiled sequence I've created. There are also tools that will help us to convert animations from one character to another with a different scale. We do discuss those tools in depth during the Advanced Character Design lesson series before getting into creating your own completely unique character animation sets. But for now, if we choose different animations, they are still referencing the standard character animations. But I did want to show you an example of what's possible so you can start getting some ideas together. For now, be careful when you're dealing with characters of varying scales. We can also create our own custom animation sequences, but they will only be accessible from within Half-Life, not necessarily Deathmatch. All the process of creating custom animations and sequences in XSI, exporting them, and then importing them into Half-Life are actually covered in the Neosis Advanced Character Design DVD. Until then, I recommend that you check out neosisinteractive.com and check out some of the cool characters others out there are creating.